solutions to first order ordinary differential equation. Last time we talked about integrating factor. We brought out some equations and we solved those equations using what integrating factor. But in the course of today's tutorial, we're talking about what Bernoulli equation, how to use Bernoulli equation to solve some problems. Now, before solving some problems using Bernoulli's approach, let's take the steps that can guide us in solving what Bernoulli's equation. Now, what are the steps to solving Bernoulli equation? The first thing is what? Identify your dependent or your independent variable. I've told you how to identify dependent and independent variables. The second thing is divide through by your dependent variable on the left hand side. Let's say you have an equation y plus 2x equal to 3 y. Now you say divide by your dependent variable. Now the first thing is to identify your dependent variable and independent variable. Then you are dividing through by what you are having on this side of the equation. So this is your what? This is your right hand side, and this is your what? Left hand side. So don't be confused. The next thing is what? Rewrite your equation in this manner. Now they say you should rewrite our equation in this manner. Rewriting the equation in this manner, you will have something like yn y prime plus px y raised to the power of what? 1 minus n, and this is equal to qx. Now if you have something like this, you can simply say what? This is the same thing as what you have here. But you can simplify this further by saying what? This is written as what? 1 over y raised to the power of n, y prime is what? Dy in respect to what? Dx plus p bracket x bracket y 1 minus n, and this is equal to qx. So if your equation is like this, you can simply say what? This is the same thing as having this. What we did here, we just simplify what we have here. The next thing is to call v to be this. So now, if you are calling an alphabet to be anything, we are taking what we have here. We are taking what? The dependent variable that we have here. We are working with what? The dependent variable. That's what we are working with. So after dividing through by the dependent variable, you have the dependent variable here. That alphabet you have here, or that value you have here, you are calling it an alphabet. Now, after calling that an alphabet, the next thing you do is you are differentiating. So you are differentiating this and you are differentiating this with respect to your what? Independent variable. We'll take some examples for more clarification. Now, the fifth step says what? Rewrite your equation in this manner. Now, if we are working with v, our equation will be written as what? The v over what? The x plus pb equals to q, where we will compare our equation to get what? P and q. Now, comparing the equation to get p and q, we have what? Maybe we have something like pb is equal to 2b. What we'll do is we cancel out b, and what? We are left with what? P is equal to 2. When we solve some example, we'll see how we are to approach some question given. The next thing is what? Apply the if statement. And our if statement says what? P is equal to exponential raised to the power of what? Integral of p dx. Now after doing that, you solve for your power, which is what? Integral of what? P dx. You get your answer. Then after that, you apply the second if statement. We did from this place, from step 5 down was what? The steps for integrating factors. Last week, we talked about integrating factor, using integrating factor to solve problems. But today's tutorial, we'll be talking about using Bernoulli to solve first ordinary differential equation, which is still what? Under ODE. Now to solve this, I gave you steps or the approach in which you use to solve the Bernoulli. I told you the first one is identify your dependent variable and your independent variable. So now let's go into the calculation. So the first thing we do is what? To identify our dependent variable and our independent variable. And I told you when you are differentiating with respect to a given variable, that variable you are differentiating it with respect to is your what? Is your independent variable. So now how many variables do we have in our equation? We have just two variables. The first one is what? We have the y and we have the x. And we said when we are differentiating with respect to, we are differentiating this equation, we are differentiating with respect to x. So our x is our what? Our x is our independent variable. While the y is what? The y is our what? Dependent variable. Now what's the next thing? The next thing is use your dependent variable on the right hand side of the equation to divide through. So let's do that. We have what? The y over what? The x plus y equal to what? X y raised to the power of what? 3. So we are using 3. That's the dependent variable on the right hand side of this equation. So we divide through. What do we have? We have divided through by 3. Divide y raised to the power of 3 divided by what? Y raised to the power of 3. So we arrive at what? Y over y raised to the power of 3 dy over what? Dx plus y raised to the power of y raised to the power of what? 3. And this is equal to what? X y raised to the power of 3 divided by y raised to the power of 3. Looking at the equation on this other side of the equation, we know that what? Our dependent variable will sort out the dependent variable. One of these will take out the y here, and we are left with what? 1 over y raised to the power of what? 3 dy over what? Dx plus 1 over y raised to the power of 2 equal to x. What do? We can rewrite this equation to look like this. Y raised to the power of what? Minus 3 dy over what? Dx plus y raised to the power of what? Minus 2 equal to x. What is the next thing we are supposed to do? The next thing in the step is what? We are rewriting our equation in this manner. And I gave you in the step that you are writing your equation to look like this. Y minus n y prime plus px y1 minus n equal to qx. Where I told you that our v is equal to y1 minus n. So now doing that to the steps, with what we have in the steps, we'll do the same thing to what we have here. So now, what can we call v? We can say what? Z is equal to what? Y raised to the power of minus 2. What's the next thing we are supposed to do? The next thing is to differentiate both sides of your equation. Now, if we differentiate both sides of your equation, we are differentiating what? Implicit. Now, doing that, we'll have what? If we differentiate this, we'll have what? 1 multiplied by what? dz over what? dx. And this is equal to minus 2y minus 2 minus 1 dy over dx. What do? You rearrange your equation. Rearranging this equation, we'll have what? We'll have that what? dz over dx is equal to minus 2y raised to the power of what? Minus 3 dy over dx. Now, look at this equation and look at what we have here. What is the difference between what we have here and what we have here? You can see that there is a slight difference between this and this. What is the slight difference? The slight difference is the minus 2. So can we use the minus 2 to multiply throughout this equation? So let's call this equation A. The next thing is multiply minus 2 throughout the equation A. Now, if we do that, we'll simply have what? Minus 2 bracket y minus 3 dy over what? dx plus y minus 2 is equal to what? X. Now, if we take these two into this equation, we'll have what? Minus 2y raised to the power of what? Minus 3 dy over what? dx. Minus, because the minus is knocking out this positive sign, we are left with a negative sign. And this is equal to what? This is what? Minus 2y raised to the power of what? Minus 2. And this is equal to minus 2x. What is the next thing? You can now see that we've achieved what we wanted to get as what? dz over dx. So we can see that everything here is the same as everything here. Now doing that, we'll have that dz over dx minus, we have 2 here. And we said that z can be represented as what? Y raised to the power of minus 2. So can we say that minus 2z, minus 2 multiplied by this z. So this is what? Minus 2, which is this 2. And we know that y raised to the power of minus 2 is what? It is z. So we can put z here, and this equation is equal to minus 2x. The next thing in our step was what? Rewrite your equation to suit this. And it is what? dy over what? dx plus py equal to q. But in our equation, we are using z as a variable here, not y. So the next thing is what? Rewrite the equation in this manner. Now what is the manner? The manner says what? dz over dx plus pz equal to q. Instead of using y, we are using what? Z, because that is the variable we are interested in. Now let's compare what we have here with what we have here. So we can say that what? Pz is equal to minus 2z. What do? We have to find p. So we can remove z from both sides of the equation. We are left with what? P is equal to minus 2. The next thing is, look at the right hand side of the equation. You have what? Q. So can we say Q is equal to minus 2x? Yes. So Q is equal to minus 2x. What is the next thing? The next thing in our step was what? Apply your if statement. Now, if you apply our if statement says what? If is equal to exponential integral of what? P dx. But we know our p to be what? Minus 2. So we can substitute p into that equation here. So we'll be left with what? If is equal to exponential integral of what? Minus 2 dx. What is the next thing? The next step was to solve for your power. Now, solve for integral of minus 2 dx. Now, if we integrate a constant, we'll add x to that constant. Now, if we integrate minus 2x dx, this is equal to minus 2x. Now, somebody will ask me, why didn't we add c to what we've integrated? We cannot add c because we are not done with our solution. Now, we are taking this back into what we have here. But we know that what? If is equal to exponential, we've solved for minus 2. So we are putting what we've solved for into that equation. We'll have what? Exponential minus 2x. The next thing is apply your if statement. Now, applying your if statement, we know that our if statement in our step was y dot what? If equal to integral of if dot q dx. But in this case, we are using what? Z. So we can say that the next thing is Z is equal to, the next thing is Z dot if equal to integral of if dot q dx. We know our Z, we know our if, and we know our q. We know that Z is standing as a constant here. Now, substitute everything you've gotten into this equation. You substitute your q into this equation, and you are substituting your what? Your if statement into this equation. So you will have what? Z dot exponential minus 2x, and this is equal to what? Integral of, what is our if? Exponential minus 2x dot, what is our q? Minus 2x dx. What do you do next? The next thing is, look at this side of the equation. It's already simplified. So can we simplify this the way we've simplified this? So this can be written as z dot exponential minus 2x, and this is equal to what? Integral of minus 2x exponential minus 2x dx. What do you think we should do next? The next thing is, we can bring out this constant outside this equation, and we'll be left with what? Z dot exponential minus 2x, and this is equal to minus 2 integral of x exponential minus 2x dx. What do you see? We can see that we brought out the constant, which is what? Minus 2, and we are left with what? Integral of x exponential minus 2x. Now, looking at this, we know that we can apply what? Integration by parts, because we have what? The integral of what? A polynomial and an exponential. So applying what? Integration by parts to simplify this equation on the right hand side of our question. So the next thing we have to do is to what? Solve for integral of x exponential minus 2x dx with the concept of integration by parts. Now, what is the concept of what? Integration by parts. The concept says what? Integral of u dv is equal to uv minus integral of v du. Now, what is our u? What is our v? And what is our du? But we know that integral of u dv is equal to the integral of what? X exponential minus 2x dx. So we can say that what? Our u is equal to what? Our polynomial, which is x. And our dv is equal to exponential minus 2x. What do you do next? The next thing is to find our what? Our v and our du. Now, to find du, what do we do to this equation? We differentiate. Now, differentiating, we have what? Du is equal to, if we differentiate x, we have what? 1. What do you think we should do to get what? V. To get v, we integrate this equation. Now, integrating this, we have what? Integral of what? dv, and this is equal to the integral of exponential minus 2x. Now, if we integrate this, we arrive at what? V. And if we integrate exponential minus 2x, we have what? Minus exponential minus 2x over 2. This is basic integration. Now, we've gotten our u, our v, our du, and our what? dv. What do you do? Substitute your known parameters into our question to get what? The unknown. How do we get the unknown? The unknown is, this is equal to, what is our u? Our u is what? X. What is our v? Our v is what? Minus exponential minus 2x over 2. What is the next thing? Subtraction. Integral of v du. We know v and we know du. So this is what? Minus integral of, what is our v? Our v is what? Minus exponential minus 2x over 2 multiplied by 1. The 1 is what? Our du. What do you do? We can simplify this by bringing out what? 1 over 2 as a constant outside. Now, minus the subtraction sign will knock out this subtraction sign. It will give you what? A positive sign. Now, doing that, we'll have what? Minus x exponential minus 2x divided by 2 plus, we are bringing out minus 1 over 2. So we left with what? 1 over 2 integral of exponential minus 2x. What do you do? We can integrate this side of the equation. Now let's integrate this side of the equation. Integrating this side of the equation, you'll be left with what? Minus x exponential minus 2x over 2. And this will give you what? Plus 1 over 2. You are integrating this. So if you integrate this, you have what? Let's bracket it. So we have minus exponential minus 2x over 2. And you are adding what? Plus c, because you are done with the integration. What do you do? We can simplify this further by saying this is equal to minus x exponential minus 2x over 2 minus exponential minus 2x over 4 plus c. But we know that everything we are solving for integral of exponential x minus 2x dx, which is this. So we can say what? We can say that we started from here, where we solved for everything here. So this is what we've been solving for. So we've gotten for this. We can substitute this into this equation. Now, if you put everything here into this equation, you arrive at what? Z exponential minus 2x, and this is equal to minus 2, and what is everything we've integrated for? Which is this. So we can bracket it to be minus x exponential minus 2x over 2. And this is what? Minus exponential minus 2x over 4 plus c. So we are using what is here to multiply through. So if you use this to multiply through this equation, you arrive at what? Z exponential minus 2x, and this is equal to minus, this minus is knocking out this minus, so you will be left with what? A positive sign. And this is what? 2x exponential minus 2x over 2. This minus is going in, so it will be what? Positive, so it will be plus 2 exponential minus 2x over 4. What do you do? This can still come into this constant. Minus will knock out this positive sign. You will be left with what? Negative sign 2c. What do you do to the equation? We can simplify this by saying that this is equal to what? Z exponential minus 2x, and this is equal to 2 is knocking out this 2. You are left with what? X exponential minus 2x plus 1 of this is knocking out this, so you are left with 1 over 2 exponential minus 2x minus 2c. You've simplified it. What do you do? The next thing is to use what you have here to divide through. So you'll be left with what? Z as a constant. Now, letting z stand alone, we have what? Divide through by exponential minus 2x. Exponential minus 2x. If you divide through by minus exponential minus 2x, we'll be left with what? Z exponential minus 2x divided by exponential minus 2x. And this is equal to what? X exponential minus 2x, which is this, divided by exponential minus 2x plus 1 over 2 exponential minus 2x divided by exponential minus 2x. And this is what? Negative 2c divided by exponential minus 2x. What do you do? We know that this can cancel out this. This is taking care of this. And this is removing this. So you are left with what? The constant z to be what? X plus 1 over 2 minus 2c all over exponential minus 2. You can still simplify what we have here. Now, simplifying what we have here, this is what? We have what? 2c over e minus 2x. Now, we can simplify this further by saying what? This is equal to 2c over 1 all over exponential 2x. So how do we do this? This can be written as 2c over 1 divided by 1 over exponential 2x. What do? We can put in a multiplication sign by inverting this. So if you do that, we have what? 2c multiplied by what? Exponential 2x over 1. Now finally, what do we have? This is multiplying. So you'll be left with what? 2c exponential 2x. So we can put this into this equation. We've simplified this. So if we put this into this equation, we have what? Z to be x plus 1 over 2 minus this, which is this. We've simplified this. So we'll be left with what? 2c exponential 2x. Now, what is the next thing? But we know that what? We called what z to be what? Z is equal to y raised to the power of minus 2. So we can substitute minus 2 into this equation. So if you do that, you'll be left with what? Y minus 2 is equal to x plus 1 over 2 minus 2c exponential 2x. What do? We have a negative sign up. Now, to remove that subtraction sign, what do? We are taking 1 over. Now, if you do that, we have 1 over y raised to the power of what? 2. And this is equal to what you have here. X plus 1 over 2 minus 2c exponential 2x. What do you think we should do next? We can take this as a whole and divide through by 1. Now if we do that, we want to remove this 1 over. We can cross multiply, or we can remove this by taking 1 over in this side of the equation. Now if you take 1 over everything here, you are left with what? This 1 over is removing out from the left hand side. So you have what? Y raised to the power of what? 2, and this is equal to 1 over x plus 1 over 2 minus 2c exponential 2x. We are done. But our question says what? Dy over dx plus y is equal to what? X y raised to the power of what? 3. and we were given what? Boundary conditions. Now these boundary conditions means that anywhere you see these variables here that we are giving a value, you substitute those values into those variables here. So now we've arrived at the last part of the question. The next thing is to substitute all these values we have for what? X and Y into this equation. Now if we substitute all these X and Y, we are left with what? C, and we have to find what? C. I told you last class when we were solving integrating factor, I told you how to apply all these steps, and it was the steps we used to solve the equation given. So now if we substitute all these boundary conditions into this question, we have what? Y to be what? 1 square, and we have what? 1 over, what is our x? Our x is what? 0 plus 1 over 2 minus 2. C is our constant, exponential 2 bracket. What is our x? Our x is what? 0. And this is what? Over 1. Now if you do that, what do you have? You can simplify this. Simplifying this, you know that anything 1 raised to the power of 2 is what? Is 1. And this is equal to 1 over 0 plus 1 over 2. We are left with what? 1 over 2 minus 2c exponential 0. We know that anything raised to the power of 0 is 1. Now, using that concept to 2c exponential 0 raised to the power of 0, we have what? 1 is equal to 1 over 2 minus 2c exponential 0. We know that exponential 0 is 1. So we have this to be what? 2c multiplied by 1. Please don't forget to drop your questions on the comment section. Now we can simplify this by what? By saying that y is equal to 1 over 2 minus 2c. Because what we have here is the same thing as 2c. What do we do? Everything here is over what? 1. So we can cross multiply. Cross multiplying, we have what? 1 multiplied by everything here. You are left with what? Everything on the right hand side. So we have what? 1 over 2 minus 2c. And this is equal to 1. What do we do? You can take this down to the other side of the equation. Now, a positive sign crossing over a unequal to sign, you have what? A negative sign. So using that concept, we have what? Minus 2c is equal to 1 minus 1 over 2. What do we do? You can do this, you can do something to this equation. We have 1 minus half, which is 1 over 2. So if you have that, we have what? Minus 2c is equal to 1 over 2. It's just like saying 1 orange, removing half orange from the full orange. You have what? A half orange. Do you use that concept to knock out what we have there? You are left with what? 1 over 2. The next thing is to make c the subject of formula. Making c the subject of formula, we are dividing through by minus 2. So divide 2 by minus 2. You are left with what? Minus 2c over minus 2, and this is equal to 1 over 2 divided by minus 2. You are left with what? C. Now c is equal to 1 over 2 multiplied by 1 over minus 2. This was the same step. This was the same concept we applied while getting a kind of value on the other side of the board. Now if we do that, we can multiply 2. Now multiplying that, we have that what? C is equal to what? 1 over minus 4. Now this is the end of the solution. We've gotten our constant. Our boundary conditions were given to us to get our constant. Now Bernoulli equation is another type of is a type of solution to ordinary differential equation. We've talked about the integrating factor, we've talked about the Bernoulli, and we'll talk about what? Separation of variables. That will be our next
topic. I told you we have 6 approach. We know the integrating factor, the Bernoulli, the separation of variable, the exact solution, homogeneous equation, and so on.